exercise 3G, it's a pretty straightforward exercise, leads nicely into 3H. The only difference is it depends on your fraction skills first. Okay, that's why I said 3B was key. So here, there's only one rule to convert anything to a percentage. Per means every. Cent means 100. So literally means you need 100 of them. Yeah? So every 100 of them. So any fractions or decimals can be converted to a percentage by simply multiplying by 100, because it literally means that you've got to have 100 of them. And here's the logic. A lot of students know this. If I ask them, what is half as a percent? So if you got 1 out of 2 right, what is your percentage score? What would you say? 50. We all seem to know it's 50%, but there's a lack of understanding. Well, why is that 50? Where'd the number 50 come from? Well, you see, half, if I literally do what they're saying, percent means for every 100. I'm actually saying I got 100 of these. 100 of these halves. So not just 1, not just 2, not just 3. I have 100 of them. But you see, every 2 makes 1. That's why when you add them all up together, if you had 100 of them all lined up, 100 of those halves, it adds up to 50. So out of the 100, you get a value of 50. That's why they say it's 50%. Or another way of thinking about it is half times 100, because you've got 100 of them. And we know here, when you times them, multiplying fractions, top with top, bottom with bottom, this is why you end up with 100 over 2, which means 100 divided by 2. And that just means 50. The total, if you added half 100 times, will actually equal to 50. But we write the percentage symbol to remind you we're talking about in groups of hundreds. That's what it means. That's why the rule is times by 100. Because the wording percent literally means every 100. That's what it actually is trying to say. Which is funny, because I find that students still don't understand that even up until year 12s. When I try to teach them, I say percent means every 100. So when you say 3/5 and you want to know what that is as a percentage, you just need 100 of them. That's all you need. Get 100 of them and that will tell you what the percentage is. So here, any of these questions, whether it's decimals or fractions, if you want to know the percentage, just get 100 of them. So here, I would say times 100. Get 100 of those and you'll find your percentage. Get 100 of these 4.5. So you got 4.5, add them 100 times, you will get your percentage. So in this case, times this by 100. So in both cases here, it's about whether you can do this by hand or whether you can do it by a calculator. For the year 12s who I'm teaching foundation maths, they don't learn the techniques anymore. You only learn that from year 7 and 9. After year 7 and 8, really, you don't learn fractions again. We assume that you know it by now. So by the time you get to year 12, it's more application, doing your taxes, doing your superannuation, home loans. We assume you know how to do percentages. Okay, so then they do this on a calculator. That's what you do in real life. As learning theory, if you plan to do algebra and then a bit more intense maths leading into engineering and physics and all that, then yes, you need to know the technique. Because technique tells me that you can think hypothetically. If you can't think hypothetically, then it's better to do applications, and that's why there's different types of maths for you to learn. Yeah? So at the year 7 to 9 stage, we teach a lot of theory. For some of you, it might not even feel relevant because it might mean that you prefer application maths rather than theoretical maths. Okay, so find where you're sort of sitting at in the next few years, and that's how you decide what kind of maths you want to choose. Are you an applied person, where you want to apply it for your everyday stuff, or are you a hypothetical person that wants to think about how I can change things, make models? Those are very different. Yeah? So here, let's do the technique. So if you don't have a calculator, you have to do this by technique. This is going back to exercise 3B. Let's convert it. This is 3/5 multiplied to now 100. How do I write 100 as a fraction? Yes, Rira. 100 over 1. Now when we multiply fractions, we usually say top with top and bottom with bottom. But before you do that, if you multiply top with top and bottom with bottom, the numbers could be really big. So your aim is to reduce it wherever you can. Now I can see 2 numbers that I can reduce. Which 2? 100 and the number 5. They both have a common factor of what? Can I please have Shreya? What's a common factor of 5 and 100? Or what number goes in both of these numbers? 5, very good. So 5 goes into 5, and 5 also goes into 100 nicely. How many 5s fit in 5, Ollie? 1, so this cancels that to be 1. How many 5s fit into 100, Luke?
20.
Yeah, very good. Becomes 20, and so your fraction now is much smaller. It's 3 over 1, as we reduced it, and that now becomes 20 over 1, which is much more preferable than doing 3 times 100 and 5 times 1. So if you multiply them now, you should then get 3 times 20, which is 60. 1 times 1 on the bottom gives you 60 over 1. But 60 over 1 is the same thing as writing what? Let's go with Zave. 60%. Very good. Because it's 60 as a value. If you added 3 fifths 100 times, if you actually did 3 fifths plus 3 fifths plus 3 fifths 100 times, the value is 60. But why do we write the percent? It's because you've got 100 of them. That percent just means you got 60 value after you add them all together equals 60 out of a total of 100 items. That's what it means. Yeah? That's why we put the percent symbol. That's why if you don't put the percent symbol, it's a wrong answer. Because we're talking about percentages, which is every 100. Next one's easier. This one you guys learned previously in 3F and 3E. Yeah, 3E and 3F, we did multiplications of decimals where they're multiples of 10. So in this case, remind me, 4.5 times 100, how do we do this? Let's go with Elijah. What's a quick way? 4.5 times 100? No, that's if you write 45 as a percent, then it'll be 45 out of 100. But I'm asking, how do you do 4.5 times 100 again? There's a quick way. Oh, you could do that. There's a better one though. There's a quicker one. Remember about the decimal points that you can move them? Yes. What's the faster way again? What's the faster way? 4.5 times 100, you can move the decimal point to the right or left? To the right by how many? 2 spots because there's 2 zeros. Okay, so 2 spots because there's 2 zeros. If you move it 2 spots, there's an empty spot here. So therefore in total, it's 450%. That's one of the exercises. 3 or 3F, we cover times 100 and then divide 100 as well. So going back and forth. Yeah? So doing decimals and doing fractions, it's the same technique. I just need 100 of them. The only difference is, can you work in 3B, fractions? Can you work in 3E and 3F, multiplication? Yeah? So that's 3G. That's pretty much 3G technique. Cool? Now where does it get tricky? You might get something like this. These ones are easy. This is the one that Elijah was answering before. When we want to write a percentage into a decimal or a fraction, he was correct in writing over 100. Because when you say 35%, percent means every 100. So in this case, he would have been right had I said, what is 45% as a fraction? Then you'd say 45 over 100. In this case, 35% just means 35 for every 100. But then to convert this to a decimal, you literally do what you see. 35, what's this symbol mean? Divide. But we literally just learnt how to multiply and divide by 100. What's 35 divided by 100? How do you do it, Harley? How do you do 35 divided by 100 quickly? Remember the moving in decimal places? Yes, but where do you move it? Left or right? Okay, we've forgotten this. That's okay. We'll go to the next one. Yuri. Left. How many? 2, because there's 2 zeros. When you divide, it gets smaller. When you multiply, it gets larger, right? So when you move to the right, it gets larger. When you move the decimal point backwards, it gets smaller. So it makes sense that dividing has to be left, right? So if you move back twice, it's 0.35. That's why that's quicker. Okay, so this is a lot quicker if you know it's dividing or multiplying multiples of 10. Yeah, so you can see I just converted percentages to fraction, fraction to decimals, and I literally was just reading it. It just means 35 for every 100, 35 for every 100, 35 divide 100. Look at that. Let's try the next one. 240%. What does this mean as a fraction? How do you write 240% as a fraction? Let's go with, who am I choosing here? Aaron.
Is it 240 over 100?
That's it, literally. It just means 240 for every 100. So 240 over 100. But if we read what it actually means, it just means 240 divided by 100. That's all it means. Now let's practice again. Dividing by 100. Do I move left or do I move right? Left. How many units? 2 place values. So 1, 2. I move it over here. So therefore the answer must be 2.4. So 2.4 as a decimal actually means 240%. 0.35 as a decimal means 35%. Okay? A common mistake that I see in the test. I usually put this one in. What do you think most students would write when they see this? Okay, we had 12.5. What's the other one? 50% is the most likely one. Okay? It's because they see the 0.5 and they think 50% straight away. But that's not my question. My question was, what's half percent? Half percent means out of 100, I have half. Not 50 out of 100. 50% means 50 for every 100. Half percent means for every 100, I only get half. It's very small. Okay? It's not 0.5, which is half. That's the common answer too. So that's another common answer. They say half, which is 0.5. See, I want you to think about the logic. If I asked you what 0.5 is as a percentage, you would have told me before 50%. But 50% is not the same. It's half percent. Can you see where the mistakes is coming in? It's because you're memorizing. Every time you see half, you think of 0.5. Every time you think of 0.5, think of 50%. But the question was, what's half percent, which means half out of 100. So the answer, this is how you do it. It's half for every 100. Now students look at this and go, I don't know how to do this. My year 12 still struggle with a fraction on fraction. It literally just means half, and what's a symbol mean? Divide. And when I write it like this for my year 12s, they're like, oh yeah, I know how to do that. But funny enough, I write it like this, they're like, oh, I've never seen it in my life. Can't do it. But like this, they're like, oh yeah, I've done that back in primary school. I'm like, great. It means the same thing. Nothing different. It's just half divide by 100. So if you think about it, half you already know as a decimal. What's half as a decimal? 0.5. So this is where your 0.5 is correct. But then the divide by 100 means move the decimal point back 2 place values. So here we go. 1, 2. Put a 0 in between the gap. And so the answer should be 0.00, because there's 2 zeros there, 5. So not 0.5, but it's 0.005 is what half a percent means. If you were to do it as a fraction from here, because some of the questions in 3G will get you to do this by hand with fractions, you literally do fraction skills. Change it to 100 over 1, KFC method, keep the first fraction, which is half. Flip the second fraction, so the 100 over 1 becomes 1 over 100. And then C, change the sign from division to times. So if you want to know what this is as a fraction, it's 1 over 200. 1 over 200 is the same as 0.005, which is the same as half a percent.
Yeah, I think when Will was explaining it, he was trying to say that it was half a percent. He just wasn't like explaining it the same way. Because 0.005 is basically just half of 1%, which is 0.01, right?
Half a percent. Half of 1%, you're correct.
Yeah.
Half of 1% is 0.5. Yeah, because 1% and then half of that would be 0.5%. Sorry, 0.5%. My bad. Yeah. Is that what you were trying to say?
Oh, no, I was trying to say half of 0.01.
Half of 0.01, which is 100 over 1 on 100. Is that what you're trying to say? Like that? Half of 0.01? Because that's correct.
Yeah.
Half of 0.01 is correct. Where'd the 0.01 come from?
I mean, 1% is 0.01.
1% is 0.01, that's correct?
Yeah.
So you're saying half of 1%, which is equal to that. Yeah, which equals to that. Which equals to that. I'm not sure. I just heard him say 0.5. So if he said 0.5%, then that's correct. But then 0.5% just means this. Yeah. All right. But that's a common mistake. As you can see why, because of that 0.5 and that half. All right, team. We got now, what's the last bit to do? Oh, this one. Can you flip over the page? Example 3. So let's say you learnt how to read percentages now. The next bit is to apply percentages. So here, for example, 32% of $20. Literally write what you see. 32% of 20. Write this down. Here we go. Shh. Eyes and ears towards the board. When you say 32% in exercise 3G, you now know how to convert that to a fraction. So what's 32% as a fraction? How do you write it as a fraction? What is it as a fraction? 32%. 32 over 100, like Jessica said. So 32 over 100. And then the 20 is over here. That makes sense. The only next thing that you got to convert in terms of language into mathematics is the word of. There's a common mistake here. Let's see if you guys get it right. What's the operation for of? Is it add, subtract, multiply, divide? Multiply. What do you think the common mistake is? Of means times. Common mistake that I hear students say is they do division. And I get it. Is because when you think of half of 10, you know the answer is 5. And then you question yourself, how did you get 5? You do 10 divided by 2. But the logic is, that's how you end up with 10 over 2. Okay, so of means times. If you didn't know that, please write that down. The word of, groups of, that actually means times. So here, when you try to find percentages, find 32% of 20. You're literally doing 32 over 100 times 20. That's what that sentence means. So here, you're back to exercise 3B. This is why I said 3B was core. If you don't know your fraction skills, you struggle here. Obviously, if you don't struggle with your fraction skills, you can type that in a calculator. 32 divided by 100, then times 20, you still get your answer. Yeah? But let's do it by hand first. 32 over 100 times 20 is a whole number, as a fraction is 20 over 1. Before you multiply top with top, bottom with bottom, see if you can simplify. I can see 2 numbers already. Which 2 numbers can you simplify? 20 and 100 is one of the easiest ones to pick up. 20 and 100, just like before, or similar to before. What's a highest common factor? Thomas? 5 is a common factor, but not the highest common factor. 20, because it can fit in 10, but it can also fit in 20. 20 is the highest. 20 into 100 and 20 into 20. That gives me 1. That gives me 5. This changes your fraction now to 32 over 5 times 1 over 1. Which actually is just the same thing as saying 32 over 5. So what's 32% of 20? It's 32 over 5. But a lot of people look at that and go, I don't understand that. That's not how we speak. So we convert it into mixed fractions so that people understand. How many 5s fit into 32?
6.
So we say it's 6 wholes, remainder? 2 over 5, very good. So you can say 6 and 2 fifths. So it's $6 and 2 fifths. But again, people might not understand that. So we convert that to decimals. And we know that 32 divided by 5 is the same thing as saying how many 5s fit into 32. This is why you are practicing exercise 3E to convert it. Here we go. 5 into 32. We know it fits 6 times. Remainder? 2. Carry the 2 over. 5 into 20. 4. So the answer is $6.40. This is the technique I want you to practice if your conversion of percentages are good. So 3G, if you can do conversions, then 3H is application. Application requires 3B. Okay, 3B, you need to be fluent with simplifying fractions and then converting fractions to decimals, that's what I'm training. Okay, so in one question, I can already see your 3B, 3E, and 3F skills from just that one section if you're doing it by hand. If you do it by a calculator, then I can't tell. Yeah, so if you use a calculator, did 32 divided 100 times 20, you get your answer, but I can't see the theory. Okay, so application-wise in real life, you just do it on the calculator, but in your case, I'm trying to see the theory to see where I can help you with your abstract thinking. Yeah? All right, team, that's 12:41 now. I'm going to stop there. Friday, when I see you, I'll teach you the unitary method where you can do it in your head. So some of the common percentages you can do in your head, but this is core. This is what I want to see. This build-up is key. So even if you've done 3B, I still want it to be retained. So for example, the other class, I had a student who smashed through the multiplication bit and was able to do really massive ones. And now 5 weeks in, I give it back to the student and they still can't do it. Okay, so it means that you might have done it once, but it doesn't mean you've retained it. You haven't actually mastered the skill. So I want you to keep practicing to have these skills mastered before next year. Next year, there's an assumption that all of this that I'm showing is done. They will literally go from this step to maybe this step to then the answer. They don't guide you through it. There's a lot of assumptions about your skills by the time you get to year 9. That's why when you choose subject selections year 9, a lot of students start to choose different maths because there's lack of support in year 9. Because we assume 7, 8, you had 2 years to practice add, subtract, multiply, divide. Add, subtract, multiply, divide. That's pretty much all we're doing this year. So you had 2 years to master it. You had grade 3, 4, 5, 6 as introduction. And then by the time you get to year 9, it's a lot of applications. A lot more algebra, a lot more applications, so theoretical. Okay, so you decide, are you more of an applied maths person or are you more of an algebraic hypothetical person? That's where you decide what kind of maths you choose for next year. Yeah? Yep. You can ask that. All right, I'll stop the video there and here we go.